Hello, everybody. Welcome back to this second session of the Knowledge Graph Construction Workshop. So, now it's the keynote. It's a pleasure to us to have Javier and Selene here to present the work that they are doing in Roche, constructing their knowledge graph. And then, I mean, we are live streaming as well in YouTube. So there are some of people that are following the keynotes online as well. First of all, thank you very much for accepting the keynote and be here with us today, although it's online stuff, but we are happy to have you here. So yeah, hope that you enjoyed this keynote. And then just starting to think your questions. I think that you will have to come here and to ask the questions here because the micro and this stuff. Okay. So yeah, Javier, Selena, the floor is yours. Thank you very much.
Thanks, David, and thanks, Anastasia, and all the organizers for this nice invitation. It's a pleasure to be here with you online and also with YouTube friends. We would like to be there face to face, but unfortunately this time it was impossible. Hopefully next time. So as mentioned, my name is Javier Fernandez, and together with my colleague Selena Bastet, we will try to show you a couple of examples of how we build a knowledge graph in Roche. In particular, we are both part of a group called Data Science Acceleration, DSX. So I think the name is very appropriate. We try to accelerate data science. And one way, of course, is via knowledge graphs. We are both PhDs in this topic of knowledge graph, semantic background, and maybe we lack of all the knowledge to find a new drug, a new medication for cancer, for COVID, but we can use knowledge graphs to create tools that help our biomedical scientists to be more efficient in all the steps of the process since the beginning, where they collect the data, where they curate, they have to clean, they have to finally analyze the data and report. So in all of this step, we can help, and we are proud of it. So the outline for today is okay. I will present briefly some introduction to FAIR and knowledge graph in Roche. Then we would like to review also one project where traditional ETL was not as good as expected. Then a quick desiderata of how we want or why we want to democratize knowledge graph, and then finally some techniques and examples where we are trying to achieve it. First of all, a quick introduction to Roche. Maybe not all of you know Roche. So as you might know, Roche is a leading pharma company developing new medicines, diagnostic for patients, which is always important, but even more in these times. We are a big family, almost 100,000 employees working around the world, of even a bigger family of patients, 127 million patients worldwide. And just to finish, Roche is also the first R&D investor in healthcare, and is among the top 10 investors across all industries, not only pharma. And as a curiosity, this year we are celebrating the 125th anniversary, and you might not believe, but it still is in the hands of the original family, the family Hoffman. Okay, now entering into the topic of clinical trials, and just trying to summarize as much as possible, and from the point of view of just the data flow. So the idea is that after years of preclinical study, of research in the laboratory, we have finally a candidate, a molecule, a treatment that is promising for something. Then we initiate a clinical trial study with a number of participants. Initially, maybe a small for safety, then with maybe thousands of people. And we start a data collection step where we collect data from a diversity of places, because we have to be also we have to take a different population into place with different type of data, lab measurements. We have demographic data, genetic information, and all of this has to be tabulated. So putting together in a huge big table with all the results, and this helps the analysis. We analyze the data using mostly traditional statistical methods, and finally we do the filing. We submit to the authorities. Hopefully at the end the treatment is in the market. So this is very easy to say, but it's hard to achieve. So normally a clinical study, maybe COVID is an exception, but usually it takes 5 to 10 years. It involves hundreds, if not thousands of people to work on that. Of course, a huge amount of resources. And it's one of these tasks where if you double the budget, it doesn't mean that you have the results in half of the time. So it's a complex task. It involves, as mentioned, multiple countries, different type of data, different formats, data also from devices that comes automatically, and still a lot of manual effort. For example, to collect the data, to curate the data, and to analyze. So at the end of the day, what we want is to maximize the value that we have for our data. So to get faster and better insights. So we want to develop more and better medicines, and that's of course the main goal. We want to drive personalized healthcare. So this is a bit new. In the traditional approach, everyone gets the same treatment. So if you have a headache, then okay, take an aspirin or ibuprofen. With personalized healthcare, it depends on your characteristics. So if you have this gene or this gene mutation, then it's better to go with this treatment. And this, for some illnesses, is already in place and it's very new. We want to reduce the time to find new treatments. So COVID is one example. And for this, sometimes you have to not create a new drug, but also repurpose an existing drug. So for example, in Roche, we had some treatment that was for arthritis, and this was used to alleviate also COVID. And at the end, we want also to faster and more effective insights. So, but still with the highest quality. So as you might know, the pharma industry is very regulated. So all of these are a bit generic, but what we want to resolve is scientific questions at your fingertips. So this means when you have the scientist has a question, like in this case, does this treatment for arthritis help in the COVID or not? Then we want to resolve this as quick as possible. And to do that, we need in practice to know where is the data. So where is the data that can help me to resolve this question? How is the data? Which is the data format? Which is the standard that is used? It's already curated. Do I have to transform it? It's ready to use? And finally, how can I connect the pieces together? Usually this data comes from different sources, and how can I link everything together? So of course, as knowledge graph researchers and practitioners also in this workshop, you might be tempted to immediately think that the solution for these questions, where is the data, how is the data, how can I connect the pieces, is knowledge graph. And in fact, yes, it is maybe one of the solutions, but we had to take one intermediate step before in Roche because not everyone knows knowledge graph. So this intermediate step is one of the intermediate steps is the EDIS program. So the EDIS program was launched, I think, 5 years ago with this aim of resolving these scientific questions at your fingertips with the objective of accelerating the science. And this was done via some principles, being fair, data share, one of them. I will mention now in a bit. So this is very well understood in the company. So this brings the company together. It's a project across the company. It's a catalyst for managing the data, new ways of managing the data, and has this vision of having the data ready for insights and with new ways to maximize this value. So I mentioned some pillars. So the first two are kind of similar: data scientist, data citizenship, and shared data. So the idea is that the data is not the data of one scientist, of a team. It's not your data. Is our data. Is the data of the company, and that's how we have to take well care of it. We have to create the data. We have to protect it, and at some point also maybe share it with the community. So just to mention, Roche was the first company that shared all the results of a study of COVID. Well, of course, with anonymized data, with patients anonymized and everything, but it was shared with the community. And finally, the other pillar and the most important for us is fair data. So fair data, maybe we don't need to introduce too much in this community. So fair data is an acronym of 13 characteristics that the data has to have in order to have good quality and be ready to use it for data science. And this is what we want. So is this the data has to be findable, accessible, interoperable, and reusable. So there was an initial manifesto and paper, and the pharma industry and Roche in particular we have rapidly embraced these principles to improve efficiency. So this is the intermediate step that we take to knowledge graph. So this is where all the pieces goes together. So we have here a mix of topics like fair data, which is at the end what we want, fair principles, linked data, knowledge graph. So what is the relationship between everything? So as we see it, this is the relationship. So we have fair principles and linked data, semantic web stack. All of this can support the creation of fair principles. When you implement linked data and you use the semantic web stack in a proper way, you can arrive to having the fair principles. On the other hand, you have the semantic web, and linked data is a way to implement knowledge graph. Knowledge graph can be also more generic. You can also have APIs as one of the nodes of knowledge graph. You can have many things that maybe is not linked data per se, but it's a way to obtain a knowledge graph. And all of these support the creation of fair data. And this is at the end what we want in the company. So in a way, just the manager of my manager, they don't know about knowledge graph, but they do know about fair, and they want to get fair data. And this is a bit of overview of some projects that we have, some stack that we have in Roche. So this is where the Roche Data Common Model. As part of EDIS, this was created to organize a bit the systems that we have, in Roche. So we have different layers of components, also verticals. So we can start maybe with the vertical, which is, I would say, maybe one of the most important reference data services. So these are services that host standards, clinical data standards, different terminology, control vocabularies that span across all the company, and this is the way we have a common understanding. And this, as Selena will present later, is based mostly on RDF. We use also SACL. We use Sparkle for some federation of queries. So Selena will present a bit later as well. Layer 1 maybe is not worth mentioning, it's just the infrastructure, the hardware. Layer 2 is where we host the data assets, so where we store all of our data. So for this, the data itself is not a knowledge graph, but we have a project now where all the metadata, all the traceability will have metadata in RDF. So this is an ongoing project for us. Layer 3 is where we harmonize data access. So in a way, different studies usually use the same standards, but they can have some variations. They can have different extensions. So in this case, what we do is to harmonize to be able to compare across studies. So for this, we also use some standards, some particular terminology that is in RDF. Layer 4, I will present a POC later. We did a POC also with RDF for integrating different data assets, integrating different sources. Layer 5 is analytics and visualization tools. And in this case, analytics, I think, well, there are some cases of using RDF, using knowledge graph, but the main point of using semantic web here is for catalogs. So we use DCAT2 based approach. So we have some nice portal that use an ontology based on DCAT2, where everyone has to submit their assets. So everyone can have the same access to this, and you can have also an APIs to access to this metadata. So this is the overview of some projects. Of course, there is much more, but this is a nice overview structure in a way that everyone can understand. Okay, so now let me present and move to this project that I mentioned before, where we use ETL-based approach, and well, we had some mixed results, let's say. So this is the so-called Pulsar project. So Pulsar is a project that wants to integrate different sources in a knowledge graph. So we want to have the data itself as RDF, not only the metadata. And the data comes from two main sources. So one being clinical data, so the actual data of the participants of different studies, mainly from cancer research. And they had two different sources, so two different standards. I don't mention much, but we had to also integrate integrate different standards for this part. And then the other part was biomedical data, biomarker data. So basically gene mutations of the participants, again, always anonymized. And this also came from different sources and with different formats. So we want to have this single point of access as a knowledge graph. We also, of course, integrate different standards and different metadata, mostly for the study. And at the end, what we want is that our scientists access this data via some dashboard, via their current analytical tools. So if they use R to analyze, if they use SAS program or Python, they can access this knowledge graph as well. And then to have some visualization tool that kind of have some statistics and some easy access of the data. So we had two main group of users. So one being data scientists that they are very well into the hands-on experience, not with knowledge graph, but with R, Python, and so on. And one with our clinical researchers, and these people are like more high level. They are more medical researchers, so they don't have so much experience on programming, for example. And they have different needs. So for instance, data scientists they want more to access and find the data, and then they know already how to analyze, how to explore. While researchers in the other way, they want to reuse some results from one study to the other, and they want to explore a bit more high level. So this is just some quick overview of some part of the graph where we have the original data, which was mainly tables. So tables that come from different formats, and at the end they are converted to CSVs. So here we have sample information, so some samples that are taken from some participants with some histology. So in this case, they are typical different types of cancer. Cells and cancers and cancer, and these are nanostring, which is a type of gene sequencing format. So here we have some genes and the value for this gene, and then we can know if something has a mutation and so on. So here we have the conversion to the graph. I mean, very basic, where we have we identify one sample entity. The sample has some histology. This very same sample has we measure the gene for this particular sample using this technique, and then we have the gene that was measured. This ZNF has some value, and then of course we will have the patient in the middle. So this was as the first step to convert to the graph. The second step was to enrich with additional data. So for example, for this particular histology, we have also some standards in our store in GDSR that Selena will mention later. For this particular gene, we can also link to external sources like GenBank. And the other thing that we wanted to semantify was also lab notes. So for instance, this lab note mentioning that one particular patient had some effects like headache and nausea. We want to create some entity recognition and put it also in the graph, so you can better connect the pieces together. And of course, this effect as well, headache, is also a standard one. So you can also link this piece together. So for this project, we use external vendor that has a lot of experience in the semantic web, and this was the promise that we can have this nice integrated layer using knowledge graph. And at the end, what we wanted to look is the same data, but with different classes. So we use a mapping language for that to convert from these original CSV files to RDF and other sources to RDF. This mapping language was ad hoc. It was created by this company. And usually we want to use standards, but okay, the promise was that with this ad hoc, it's from the company, so you can customize something easily. If we have to create something that is not part of the kind of a standard, then they can create it easily. And also it came with a UI that in a way non-semantic experts can work with it. And this is what we wanted, that the experts could also help in this mapping process. For the ingestion, just to have it in the graph, it was promised also that it could be an efficient task, almost with no supervision. Click the button, have your RDF graph, interoperable, because when you have it in RDF, then of course you can put it in any standard RDF store, and with version control, so we can have different versions at different moment in time. For the integration, so the external and internal linkage, it should be easy because the terms are more or less standard, so we can find the name or the ID in other databases and more or less out of the box. And at the end, the semantic value is that, okay, we remove the manual effort of integrating this information. So click the button, you have all these sources integrated in one knowledge graph, and then the scientist can access this integrated data, and you can get novel insights having all of this data in one pod. The reality, of course, is not always as nice as the promise. So for the mapping language, at the end, it was not scalable. So this non-standard language, it was difficult to manage. It was not very well documented, only internally in the company. The UI at the end, it was not usable. So even if you are not expert, even for me that I was more or less more expert, it was difficult to use. It was only for simple cases. If you had to use a complex case, a complex transformation, that you needed to go to this language, which was complex as mentioned. It had no version control, so we couldn't know which mapping was applied, which version of the mapping was applied. For the ingestion, it seems an easy process, just convert it to a graph, but it's not as easy as possible. And if you have work with some transformation tool, this is also a tricky piece. So for example, we had many QC effort. Things like dates were not converted properly. In our area, it's very important to have the exact date, because then this can affect when someone took a medicament, a treatment, the effects, and so on. So we need almost millisecond precision, and this was not the case with these tools to convert to the graph. We didn't have parallel processing, so we needed to ingest as fast as possible, and the tool was not ready for that. Again, problem of documentation. We use also, we move away from this approach of the company, and we had some open source tools to map, and we had these issues as well, and clear documentation, problem with big files. So some tools, research tools, they were not ready for our big files, and again, this parallel processing as well, it was not there, so it was difficult to do it. For the integration, it's not as simple as it can seem. Even if something is a standard, there are different ways to name the things. We need expert knowledge to have this disambiguation. So in our domain, two things that are almost the same, they are not exactly the same. So we need this expert knowledge, and at the end, it was also a hard process. And even we had some another vendor who had some database of curated terms that we can link to, but in that case, again, we have this vendor lock. It's not a standard. So if tomorrow we need to get away from this vendor, or we want to use another solution, we are locked to this vendor that had some open knowledge but already curated. And at the end, the semantic value is that this is very nice, but it's a huge effort of mapping, of ingestion, of curating, of linking, and at the end, our scientists didn't find that they obtained new insights with all of this information. They had the standard ways of getting this information with other processes like R, Python, and so on. So maybe it's longer effort, but they were used to other approach. So at the end, this POC didn't continue, at least for now. But we learn a lot of things, and we will mention some of this learning in the future. And one of the learnings is, of course, to democratize this knowledge graph creation. So, well, just some summary of all of this. It was easy to create this knowledge graph. At the end, we had this knowledge graph. It's not difficult to build one very nice car, but it's very hard to scale this. It's very difficult to build 1 million cars. This was one of our learnings. So more learnings kind of group into this desiderata. So this is a group some of the learnings that we had for scaling or democratizing the knowledge graph construction. So it's almost a wish list. So first of all, having FAIR by design. So as mentioned, knowledge graph can support FAIR, but only if it's carefully created. So when creating knowledge graph, we want to make sure that the metadata and the data is born fair since the beginning, and of course, it continues to be fair along all the process. We need to encompass a data governance strategy. So as I mentioned before, the biomedical industry is highly regulated, so we have since the beginning very hard standards, very hard processes, different roles, standards for everything. So, and if we introduce another piece in the puzzle, knowledge graph, they should also embrace this. So they should also embrace and support efficiently all these existing processes, roles, policies, and quality standards. We need to leverage the expert knowledge. So in the example that I showed you before with Pulsar and in traditional ETL processes, okay, it's a bit exaggerated, but we let the expert behave a bit wildly since the beginning with different sources, different standards, different format. And at the end, given that we have this problematic, this mesh, then we have to fix it. We fix it at the end with ETL, and yet we need to ask them more time of them, which is very valuable, to fix all of this. So we think that is too late. We want to put a bit more of effort in the beginning so that this expert can have their time in the beginning, which is also a good place because they are not so stressed as in the latest phases where the deadline is a bit closer. So we can put a bit more effort in the beginning so that, as I mentioned, this data is already born fair. And finally, it has to be sustainable. So we want that this knowledge graph construction, that we want to use open tools and open standards, avoiding as much as possible this vendor lock-in. So if tomorrow a vendor has a high price, or we find another solution, then we can move it quickly. Okay, so with this, we have different techniques and showcase showing this democratization. So we have what we call native technique, hybrid technique, and also virtualization. Virtualization is something new that we are exploring now. So in this talk, in the rest of the talk, we will focus more on native and hybrid approach. And I think Selena will start with the native approach.
Thank you, Javier. Do you mind if I can share my screen properly?
Yes.
Thank you. So, first thing first, thanks a lot to David, to Anastasia, and all the organizers for the invitation. Very happy to be here, to share a little bit with you on what we are doing, and also get some feedback, hopefully, from you on avenues for advancing our work here. So on techniques and showcases, probably we can already imagine why we would have different techniques is basically because different problems would call for different solutions, but not only. Actually, in our case, what we saw that it's also the setup and the stakeholder profiles that will favor one of the options over the others. Sometimes it's also the scalability needs, and yeah, the different aspects. So starting maybe with the native authoring capabilities for constructing knowledge graphs, the context here was allowing, let's say, inviting for trying out this native approach. And why is this? Because we were in the meta data space and not in the data space where volume and scalability would make it even more problematic. So just to share a little bit of context with you on where we use this technique, it's always in the universe of clinical trials. All our examples today are withdrawn from here. And here we are talking about not one particular step of this clinical trial pipeline that Javier shared already, but more on the overarching standardization of this pipeline. So the clinical trial is something that would be spanned over a couple of years to 10 years in some cases, or even longer. And actually, even before the study starts, all those parts of the study, from how the data is collected to how it's tabulated, and also the analysis that the data scientists will run, this all is governed and is regulated by what's called the study design or the study blueprint. And here it's the study teams basically choosing and selecting from corpus of standards how the different parts of the clinical trials will be conducted. And since it's a highly regulated environment, you can imagine the study teams are not really free to choose from whatever or to come up with their own definitions of how a phase in the study will be conducted. Rather, they're always referring to a body of standards that are agreed on different parties in the industries. And that's what we have in the CD standards in pharma usually. So there's a wide established standards that are mostly about the data collection that are required for submission to the health authorities. So we try always to align with these when designing the clinical trials, but also in Roche, in addition to these, we have what we call the Roche extensions to the data standards. It's also a collection of standards that governs all these different parts. And the motivation for this extension in Roche is basically harmonizing across the different study design across all the pharma trials. So those standards put together, they're stored in a system actually. This system is GDSR, and it's the vertical that Javier was talking about a little bit earlier when he showed the Roche data commons model. So it's a reference data system that is built on top of semantic technologies. And this way of building the system using knowledge graphs and semantic technology is basically a proof or like an indicator of how well embedded the semantic culture and knowledge graphs is in Roche. So GDSR is basically a system where catalogs of those standards are maintained, exposed as fair resources, machine readable, to enable automation across the different articulation points in this clinical trial. Now, the automation is not widely explored or achieved yet, but you will see, as Javier will also present a little bit later, thanks to these knowledge graph formats and machine readable format, we could already leverage and exploit these potentials of automating the pipeline. So maybe I can give you a little bit more of information on the GDSR itself. It's not the core topic of today's talk for sure, but just to give a bit of context on what kind of editor we are talking about. It's an editor that would serve as an entry point into the data standards that are stored in the GDSR. And the GDSR itself is something not very new, unlike the editor that we will be presenting today. GDSR exists for more than 10 years now. It was first created around 2010, and the main purpose was serving as a single point of truth for the data standards across Roche, mostly clinical, but not only. And then when the EDIS program that Javier was mentioning came a bit later, like 5 years later or so, GDSR also became one of those key systems that are provisioning and providing data standards across all the Roche data commons layer. The technology, as I mentioned, that is used here is mostly the semantic web stack of technologies, mostly RDF Sparkle, now more recently also Shackle, but many others. And in terms of main features, GDSR allows the management and exposure of fair resources as RDF resources, and it allows the categorizing and versioning of these. So there are periodic publications of these standards that are only possible thanks to the versioning capabilities of the GDSR. So with this system very, very well embedded in Roche, there's clearly no question about the value of semantics and having data standards in these knowledge graph formats. However, a problem still persisted for long, that in order to leverage on this value of RDF resources and knowledge graphs, we needed them populated first, right? And for quite a few years before introducing the editor, we had our users like not directly interacting with the GDSR as a system, populating the knowledge graphs. What we had as a setup was simply an expert group of users who are deciding whether something is actually a standard that is something to be utilized across different studies, or something is a data-specific definition that will be only used in scope of one study. So there is a group in Roche who decides actually if something is a good candidate for a standard or not. And once it's a good candidate, then it will be entered into the GDSR as a standard, right? As an RDF resource at the end of the day. However, those decisions that were taken by the group of the subject matter experts, or in our case, the data standards manager, were not easily, let's say, or instantly reflected into the content in GDSR because of, as you can imagine, a subject an expert bottleneck, if you want. And here, the expert in this case is the semantic expert, right? If you want to add a resource to populate a knowledge graph, you would at least need a little bit of expertise on how knowledge graphs are constructed, the different serialization, etc. So with this, we had a setup where, okay, study team needs something. They would communicate this with the data standards manager, who would eventually want to include it in the GDSR, but since they're not the expert, they would ask us, a group of 2-3 information architects, to do this, to enter the new standard into the GDSR. And the way we've done this before is using a third-party tool, just an editor for RDF resources. There are many, some of them are open source, some are paid. We used one of them, and then we could enter this into the GDSR. But before it was in the GDSR, we always version control the resources, and then only made it available in the GDSR via an admin. So as you can see here, what I was describing is a lengthy process that could have become much more efficient and shortened if a direct interface to the GDSR as a system was available to the non-expert to use and to directly enter their resources. And that's exactly what we attempted here, given that, again, we are in the meta standard space, that what we needed is really a direct interface so that the user can manage and feel empowered to own and maintain resources, even if they are RDF resources and they're not very expert in that. So that's exactly what we did. But before deciding on how this editor would look like, we went through a small or big business analysis exercise where we tried to understand from the non-experts, like how would an interface to construct and populate knowledge graphs should look like for you to feel empowered to democratize the semantic technologies. And it turns out that maybe the way to democratization is via abstraction here in our case. So what the users wanted is a simple interface where they can, as non-experts, create and edit, delete content from the knowledge graph without necessarily knowing it's a knowledge graph in the backend. And that's what we did here in the editor. And then combined it as well with a few other modules that will serve, for example, the user with checking the uniqueness of a resource, also some governance aspects of the resources that are introduced in the editor, and finally maybe a list of queries that they can use to extract knowledge graph content. I don't know if we would have a little bit of time, but I'd like to maybe do a very quick demo on this interface for you. Let me see. Can you see my other screen, or it's still the same? Very good. So this is the Workbench interface, which is this editor of the GDSR system that was introduced only a year and a half ago or something like this. And in it, you see the very same modules that I was just showing in the slides, with a little addition of an admin module. And that's only because I, as an information architect, have access to this one in addition. Maybe to start, I can show you a little bit of this admin panel, because it can show you how the editor itself is constructed, where we have different models that are available for editing purposes via the non-expert. And then we have also the different modules that can be switched on and off via the information architect for the users. And the whole, the workbench itself, is, as the editor, can be put into read-only mode or read-write, depending on how we, together with the experts, are actually sharing the same set of graphs that we sometimes still edit using a third-party tool and sometimes via the workbench. And to facilitate a little bit the process, we can turn the editor on and off, so we can also intervene sometimes in the process and do some changes for them. So without taking too much time, let me show you the editor itself. So the editor is constructed around models. So I mentioned this pipeline of clinical trials, and then there were phases in it. For example, for the collection part, you would use standards around collection form, what we call collection form. They can be electronic or not. And there are models that are actually related to this part of the clinical trial. So we would have the ECRF and non-CRF. And then across the whole, there's also, for example, what we call control terminology. So the workbench editor here reflects one-to-one the way the standards themselves are grouped in different models. Let's take, for example, the control terminology one. And here you can see the CDISC part and the Roche part. I mentioned CDISC as a industry standards and Roche as an extension. So let's maybe see how it would look like if we would like to browse and edit a resource in the Roche extension of the controlled vocabularies. So here I have a query, a kind of a search query to find first a resource that I want. And in the backend, usually this is a little sparkle that's fetching resources for me. And then as a non-expert user, I can just find the resource I'm looking for. And then in this intuitive and business-driven view, do the changes to the resources without actually knowing what's going on in the backend necessarily. Okay. So, and then there's validation kicking in the backend. So the integrity of the data is also taken care of by the editor itself. As you can see, it's like very intuitive. It's just like any other system you would work with, as if there's a relational database in the backend. This layer of abstraction is there for users. And then you can also create new resources. Okay, and as I will try to mention also in a bit, all of these interfaces are actually generated using Shackle. So I will be showing a bit also of these. And as you see here, the mandatory fields are also something that the Shackle that we use is indicating to the engine that, okay, here we would need at least like a cardinality of one minimum, and that's because it's something that is mentioned in the Shackle shape that is used to generate these views. Also, in terms of how the schema and the graphs are constructed, sometimes we have relationships between different resources, right? So what we have here is a resource having different literal properties, and sometimes there are also other resources that are related to a resource. And also using Shackle views, we can represent these related resources in a different view, like what we have here, a code list having different terms. So in here, I can actually link to existing resources that are already in the graph. So let's say here, I want to search for something that has to do with, I don't know, diagnostics. So I can link existing terms in the backend, creating binding triples between these resources that I just created and other resources. Do we have anything with? Should probably use the term as a search. Okay. So as you can see here, those terms were attached. And then I can also probably, instead of linking to existing resources in the graph, I can also expand the graph by creating new entities in this graph. This would be either using a form-based view, or also what the user actually like, and something we're experimenting with at the moment, is using a bulk view, bulk editor view. And that's because our users are so attached to the way they used to work before with Excel sheets that offered a lot of flexibility. So we try here to offer a similar experience for them, even if it's also a knowledge graph in the backend. So for this, I will have prepared a little bit of mock-up demo. Take it and then show you how this component works. And as you can see, I left a little bit some gaps here because I want to demonstrate for you the validation that will kick in when there's a cardinality, a minimum cardinality required, and it's not there. So here, as you can see, the editor is complaining. So I have to provide a value, and then there will be another validation that will kick in here, where it will tell me that you should have provided also the sponsor term. And the reason here we have two different layers of validation that I will also explain in a second. It's also based on the shackle validation. Some of them are provided at the property level, some others are more sophisticated and needs a little bit of sparkle rule so that they can kick in. So both of them are also integrated in the editor. Just to show you a little bit in the background what's happening. So you've seen the editor as an interface, but in the background there is the graph that is getting constructed. So here I know that my resource was created in the terminology graph. This is, by the way, the admin panel interface of the GDSR. And as you can see here, this graph was modified. And we have, quickly show TTL serialization of the resource. I don't know if you can see the turtle, but yeah, here is the resources that were created and also the different triples that are associated with it. So in essence, you get the idea of the editor, that it's something that's model driven, that's created out of the schemas that we have. Just find my slides here. So it's created out of the schemas that we have, and it's very intuitive and business friendly. So the question is how we could get from using only third-party tools and this long process into an intuitive and easy to use editor, all while also keeping it model driven. So having different models that correspond to the schemas that we have actually in our catalog. And the answer to this was simply we relied a lot on the existing technology, that's the GDSR technology, which already exposed an API where you can use for editing a resource, for exposing a resource, or for deleting a resource. Back then, in the days of GDSR, it was not yet GraphQL, but we had our own implementation of what we call facets that were used for this purpose. So we relied a lot on this. We also use a lot of standards. So I mentioned Shackle already in the demo. It's actually Shackle that allowed us to kickstart the development of this editor, because we used Shackle not only for validation, but we use it also for generating those different views that you've seen. In principle, it was mostly the shackle namespace that we used, but in some cases, the expressivity needed a little bit of a push, and it's here where we used an extension also in Roche for that purpose. And finally, we relied a lot on inferencing, mostly because most of what you need is already in the model schema. It's already in the ontologies that you have in your catalog. And there's not always a need to redefine everything from scratch. So where possible, you would just take your ontology, the schema, and then write a small inference rule to generate the shapes out of it. And then from the shapes, you could also generate the facets that you could use to manage the editing of the resources. So this is also something we used a lot, that we leveraged to create the views. So here, just a quick example of what a shape would look like, because as mentioned, those different properties that you saw in the editor, they're coming from a shape behind. The shape is what actually tells the editor, okay, I have these properties that I want to expose for a resource, and for some of these, they are mandatory. So how this would look like is basically every view is a shape, is a node shape, is something that you express using the shackle ontology, and it has a bunch of properties. And properties themselves are also, like in here, in this case, they are blank nodes, but they could also be named resources, where you say for each property, what's the path that's used, if there's minimum and maximum cardinality, etc. As you see here, most of the predicates that are used are the SH predicates, which are the shackle namespace. But in cases, some cases we needed a little bit of a push into, or like a gentle push into the expressiveness of the shackle ontology. And for example, cases where we wanted something to be there in the form, but not to be visible to the user. So we needed something to say, okay, I want these to be hidden, or sometimes to change the display mode, or having conditional editability of a resource. So all these kind of things where we needed to express something that was not available in the shackle namespace, we had to create a little bit an extension of it. We call the GDSR shackle. So it's a namespace we used developing these together with some functions as well, like concat, qualesky, etc. Here I can probably skip in the interest of time, just an example of the facet generation rule, so how to move from a shape into the API that is also used together with the shape. And then I can only maybe mention a word or two about the shackle for business rules validation. So the shape that I just shared before already said that certain properties, for example, are mandatory, or certain properties are constant or read-only. But there are cases where you would need to do a little bit more of a sophisticated validation before a resource is being edited, and namely in a transaction mode. For example, to guarantee the uniqueness of something that's being created, not purely based on its identifier, but also based on the values for the different properties for a given resource. So these kind of things, you would, instead of doing only in the properties of a given view, you would have to use a little bit of a Sparkle query that you usually associate with your shape, and that will be triggered upon the creation of the resource. And that's also one example of how we use a shackle on two different levels for the validation. Maybe what's worth mentioning a little bit here is, okay, even with these, the shackle is a very good head start into developing these model-driven views, and also the validation and transaction mode. It feels as if it's done. Actually, it's we're not quite there yet. There's still questions to resolve on, for example, the kind of validation that are triggered by default, or those ones that in some cases you want to override, like for example, the case of deleting a resource. What do you do with cascade delete? Do you enforce a global validation rule where you say you don't accept a delete operation of a resource that's used or has incoming properties for another resource? This is what we do, but it turns out that sometimes you'd still want to provide a little bit more flexibility, and you provide a little bit of a cascading order of the validation rules to be triggered. Also, we've learned a little bit that, okay, performance also is something that we need to fine tune a little bit with these validations, because sometimes when the scope is too big, when you're running the validation, it's a little bit lacking in the interface, and these kind of things that we are still experimenting with using the shackle. I think this would be it for the native. Maybe leave it to Javier to continue with the other approaches we've also used.
I think we don't have much time, right? So maybe I can mention one word, conclude, and we can have maybe 1 minute for questions. So in the interest of time, I have reduced many of the things. So just mention one approach that we use with this hybrid approach. So hybrid we mentioned because we use traditional approach like ETL with also some help from the users in the beginning, also in the end. So in this case, again, I don't have time to explain everything, but we have a transformation of languages. So from the data that we collect to some final format. And to do that, we use a program that uses NLP techniques to do this transformation. It's called Honeybee. But this NLP cannot be done on the actual data because it was quite messy. So what we did is just to ask users to curate this information. So this is the first intervention of the user to curate the data and also to provide some QC information to know that the NLP was done correctly. So our program, Honeybee, creates the graph and also use this QC to compare and see, provide a report to validate the final output. And then this final graph is stored in the GDSR that Selena presented, and this is maintained then later with the user. So at the end, once we have the ETL and once we have the graph, then we have the workbench that Selena presented to maintain the final graph. So that's why we call it hybrid. So we need some user intervention in the beginning, we do ETL, and then at the end, we have this editor so the user can already maintain this part. This was a process that, sorry, I had to skip this one, but this was a process that took 1.5 years to complete. We had to create 100,000 rules to do this transformation of the language. But it was a success story of transformation because then these rules are used to transform this transformation of the language automatically. And of course, we are using the workbench, but we are also thinking of extending this because for some users, it's still they are not trained with the workbench, so maybe they have to use another UI as well. So just to conclude, we try to do in ROS the knowledge graph way, the easy way. So they are deeply embedded in the ROS ecosystems. They are a basic instrument to ensure that we have fair by design. We have shown a bit that we have different users with different needs to create the data to interact with the knowledge graph. And as Selena mentioned, we have semantic experts, information architects that are not really creating the knowledge graph, or we don't want to that our work is just painful creation of resources, but we are facilitators to tailor solution for these empowered users. We are also working with other routes for creating knowledge graph. So we are exploring OBDA. So we have a project where we have an ontology, and we use that to access different systems, mostly relational databases, but also documents like MongoDB. And we are also working on this solution for even simplify it even more the UI. So maybe relaxating a bit the part of constraints, of cycle and so on, and just focus on user experience so they can very easily access to the knowledge graph and edit it. So I think that's all. Sorry for if we extended a bit. I hope we have still some minutes for questions.
Thank you very much. I think that we can. Questions? Just come here, and if you have any other question, just come in here and
Thanks a lot for the presentation. So my first question is about the harmonization that you're performing. For instance, as you also mentioned, the reality is that there are more than one standard. So how are you exactly, or what tools are you using for harmonizing, for example, genomic data?
Yeah, it's a tricky, it's a good one, and it's a tricky solution. For biomarker data, we are not harmonizing. For clinical data, we have kind of dictionaries of synonyms that we can use to try to harmonize data. We have expert knowledge, and we are mostly based on use cases. So we don't harmonize unless it's totally necessary, and only for few cases that we know for sure that that we can do it. But yeah, it's a tricky question.
Mm-hmm. And another question about, okay, sorry. So another question about basically the accessibility, so to say, and also the data privacy. So how are you handling to have the data accessible and at the same time basically considering that, for example, I don't know if you're also following the GDPR based on your location. Yeah.
Sure. We are using that also. This latest SREM 2, I think it's called. So it's something that, of course, we have to be aware. We have different access policies. So as Lena can mention as well, but even the workbench is enabled so that you can only access what you are intended to access or to edit. And we try to embed also this in the knowledge graph. So doing these policies even at the knowledge graph level. So the GDSR is also ready for that. We have other systems that also use knowledge graph and other colleagues that are also restricting access to the knowledge graph, to the pieces of the knowledge graph, depending on your access. So we are doing that indeed. It's a tricky question as well. So for instance, depending on the vendor, they cannot allow for that. So this is something that we ask. One of the first questions that we ask when we have some vendor interaction or we want to explore some tool. Okay, can you limit the access? You have access control. Is it at the level of triple? Is it at the level of the graph, and so on? So
because I guess you may have also a problem with storing the data, specifically if they're clinical data. Maybe you don't have possibility to materialize the knowledge graph, or you sometimes have the permission. I don't know how you are handling that. So yeah. I mean, should you also have like your pipeline should also cover like virtual access to the data which is stored from in the hospital, or for instance?
Yeah, for the POC that we did that I show, it was already anonymized data. And it was already kind of, okay, this is the subset that you can use for the POC. So this was easy. For some of the parts we use, because it's metadata, then we kind of the metadata can be used. It's not kind of private. For other part, we have, as mentioned, some anonymization rules. So when we have to do some analysis, we are already anonymized, and we follow all the procedures to be compliant with GDPR. But we haven't explored this case, or we didn't have this use case where we had to virtualize. Maybe with this new use case we have it, where we have to virtualize and the data has different access policy. This is a good point. Let's see when we arrive to that how we can do it.
Thank you.
Thank you.
Just to add to this, yes, Javier, for example, for us in the editor of the workbench, we didn't need to deal with that, and simply because we're in the metadata layer, it's about standards. There's no subject records, and therefore, yeah, GDPR was luckily out of scope for us. But very good point, yeah.
Okay. Any other question? Okay.
Yeah, I also have a short question. So you mentioned that you are also dealing with the patient data and also like these electronic records of the patients. So every doctor has their own style of writing or prescriptions, certain medications, or talking about the diseases. How you are handling those different patterns of the writing, because they are not well organized in writing different things. So how you are tackling these differences?
Yeah, thanks for the question. Yeah, indeed, it's a big problem. So I would say that we have an army of so-called curators and integrators. So these are the domain experts that they know all of these tricks, they know all of these synonyms. They use dictionaries to help, but it's a manual effort right now. So it's almost a manual effort to harmonize all of this. And I can say that there is a project now also trying to automatize this curation. So they want to use different techniques, noise graph being one of them, but they want also to explore, advanced analytics and machine learning to try to automatize as much as possible. So try to say that, okay, these two things are the same, or under these circumstances, these things are the same. But so much is almost a manual effort with the help of some programs and dictionaries. But until now, it's very manual. It's a manual process.
Okay, thank you.
Thank you.
Any other question? I think we have a question from Frank, which is following Frank Michel, who is following the keynote in YouTube, and he would like to know that did you use an existing workflow enhancement framework engine to organize all of the steps from collections of raw data to publication as knowledge graphs?
Mm-hmm. No, indeed, it was we came with this workflow and all this governance. I mean, we based on the governance that we had already, as mentioned by Selena, in our standard group. But for this workflow, we didn't follow anything. It would be good to know if something more standard exists. Yeah, could be good to have a pointer.
Okay, good. And if there is no more questions, again, thanks a lot for the presentation.
Thank you. Enjoy.
Thank you very much for being here. And yeah, we will move forward to the next slot. Thank you very much for being here.
Thank you. The workshop. Thank you.
Thank you. Bye.
Okay. Bye-bye.
Bye.
Okay, good. So yeah, I think that now it's time for Vasilis and Nora that they will presenting the SemTab challenge and the kickoff of this year. Okay.
Thank you for inviting us to advertise the SemTab challenge, the semantic web challenge on tabular data to knowledge graph matching. This is a ESWC challenge, and this is actually the 4th edition of this challenge, the 4th year that we are organizing this, along with these nice people, so that they have been involved in the previous, at some point in some edition of this challenge. And for example, this year we have Nora here and Madeline for the first time as co-organizers, and we are very happy for that. Before they were participants, so they will bring very useful insights to the new challenge. So we're just quickly going to see a few things about the challenge tasks and the previous editions and participation, and then very briefly, what were the systems that won this challenge last year, and the new challenge that we are trying to organize this year. We are organizing this year. So quickly, the motivation is we have that tabular data everywhere. So the point is that we want to understand what this tabular data is about. So one way to do it is to link them to some target knowledge graph, for example, Wikidata or DBpedia, and those were the targets last year. And when I say link them to a knowledge graph, we have some specific tasks that do this linking. So the 3 core tasks that did this are related to this linking are CA, CPA, and CTA. So what this means is that we try to match each cell of a table to an entity in the target knowledge graph. And then once we do that, or once the system participants do that, then another task is to link a whole column to a property in the knowledge graph or a class in the knowledge graph, like a city or a country. And then a third task is, okay, we have annotated the cells, we have annotated the columns. So now can we identify relationships between the different columns? So can we link a pair of columns to a knowledge graph relation, an object property in an ontology, let's say. So for last year, we used Wikidata and DBpedia, and also in one of the rounds, schema.org. Okay, to put it more as an image, so the three tasks is, let's say on the table on the left, we try to identify a cell like China to the corresponding entity in DBpedia or Congo, and then the whole column to the class country, and then the second column to a city, because all the cells there are cities. And then the third task is to identify that actually the second column is describing the capital of the first column. So those are the three tasks. And of course, there are some difficulties, some challenges. For example, here we may have two different countries with annotated here with depicted here with the same name, like Congo. There are two different countries that can may be related to this label. There are missing values, so we may not know always the capital of a country in a table, or we may have errors, of course. This can be a wrong city, a wrong capital, or even some typos, things like that. And of course, we may have numbers, which makes things more difficult, especially if there are small deviations. So it's difficult to match exactly the values from the target knowledge graph. So what we have been doing, and we will continue do, we'll do the same thing this year, is that we have different rounds. The first round, let's say, is just an introduction, and we try to be kind, and we have some easy annotation tasks, easier than the rest. So there we have some automated benchmark data sets. For example, we run a Sparkle query on Wikidata, and we get the results in the form of a table. We already know, of course, their annotation. So we ask the participants, when we give them a table of the Sparkle results, to try to link those results to the source of this query, like Wikidata. So this is from the rounds from last year to 2021. And then we also have some manually annotated tables. So those are more difficult to annotate because we really try to make them difficult. So we try to make challenges that participants maybe will not expect. And then the third round is the last one. There, as we did last year, we also ask for data set contributions. So in the first round or the first two rounds, we also ask participants to contribute with data sets. And then in the third round, if we find some challenging data sets, we may also ask other participants to annotate the data sets submitted by different participants. And you can find all the resources in the links you can see below. Actually, there was a resource paper that we presented a couple of years ago at ESWC on how we generated those first editions of this challenge. So in the last few years, we have seen some active participation in this challenge. We hope to see the same this year. In different rounds of, as you see, usually the participation drops because it's becoming more difficult. So people decide to maybe sometimes to drop the challenge, but we have some core participants over the years, and we are happy that they continue submitting their systems. And of course, as the years over the years, we are trying to make the challenge more difficult. So it's becoming harder for. It's actually a challenge, so we try to make it a challenge. Okay, so now Nora will discuss about the results of last year.
Okay. Thanks, Vasilis, for the introduction. In the few slides more, I tried to give you some insights about the scores of the participants in terms of 3 tracks announced last year in the SemTab challenge. The first one is the accuracy track. And here we have the table with the average F1 score by all the participants. And the first 2 rows on this task actually shows all the variations of the data sets published last year. In the last 2 or 3 columns, I will try to give you an overview about that, the data set characteristics as they were submitted by the community. For the average one, average F1 score, the lowest scores are for those data sets from the community. So they seems to be a bit more challenging than those in the automatically generated for the first 2 rounds. This slide actually reflects the top F1 score, and again, the lowest goes to the Git tables, so easier for the DBpedia targets or the schema.org, and also followed by the BioDev dataset. However, this is not the case with the automatically generated, which reaches up to the 97% like F1 score. For the top system, per dataset and round, this table actually shows a diversity of winning systems. And if we look to the table, we see that the Dagobah system is the most winning system, I would say. So that's why it is awarded the first prize by IBM Research from the last year. The second track is actually a usability track. And in this case, we try to address a pain point by the community where the systems or the participants lack the publicly available, easy to use resources or generic solutions. And the evaluation criteria goes like follows. If the participant share an open source code, and actually if it requires a specific platform or extensive training time. In addition, we also check if the participant provide a public service to access their system, and if it provides a GUI for it. For this usability track, we have again a diversity of systems where the check marks goes to each criterion, I would say. For here we have like 3 check marks by the MTAP, so it has the first prize certificate for the usability track, and followed by the second prize for YNTAP system. The last one actually concerns the data set submissions, and it's called the last year applications track. Here I give you the overview of the 2 submissions. The first one is the BioDev tab. It's actually a domain specific for biodiversity data collection, and it consists of 50 tables, where the annotation tasks is only the cell annotation task and also the column type annotation, where the target knowledge graph is Wikidata. The second one for Git tables, it's actually an adapted version of the large scale Git table, which is a synthetic dataset crawled from GitHub tables, where it supports only the column type annotation, and it targets DBpedia and schema.org target knowledge graph. For this track, BioDev tab is actually the first prize winner here. And now I hand it back to Vasilis.
So, okay, we are close to the end. What we have been doing the last years, we have published our own proceedings. So you can find all the systems descriptions in the links you can find there. Maybe we can also share the slides later. And we have the on the challenges website, you can find all the previous editions, all the data sets, the results, so the accuracy results, everything is publicly accessible on the website. So for this year, we are almost ready to open the first round. It starts in a few days, actually. So we would like to invite you to participate. As Nora mentioned, we have the accuracy track that I described before with the three tasks of matching cells, columns, and pairs of columns to a knowledge graph. And we also have a datasets track, almost replacing the applications track. So we are more focused now on datasets submissions. And for both tracks, we have an artifacts availability badge. So I think it will be described in the next slide. So for datasets, we're just looking for datasets that we could use for challenging these systems that want to participate. Ideally, we want to have ground truth to a knowledge graph. We don't care if it's a cross-domain or a domain-specific knowledge graph. But what we want to see, what we like to see, is new challenges that we hadn't already prepared for the already existing datasets. And for the artifacts availability badge, we don't really award, give an award or give a monetary prize, but we give a badge. Okay, that's also nice. Just to motivate participants to make their code open source, so it gives more view to their system, and it's better for the community, so we can all use their system and see how well it does. And if it's documented, of course, it's even better. So we try to give a badge to systems or datasets that fulfill those criteria. And that's it. So we are ready to receive your system submissions in a few days. And I would also like to thank IBM Research and Sirius for supporting this challenge with monetary prizes. So that's another motivation for participants. The best performing systems get some recognition through some monetary awards. And okay, since we are also in the knowledge graph construction workshop, some of the co-organizers, we are also co-editing a special issue on the Journal of Web Semantics that is especially on the knowledge graph construction. So I think shortly we will have the first papers published, and you can stay tuned to find something useful for this community. Okay, that's all. Thank you.
Okay, so yeah, we can close the session here. Yeah, we will start at 2 again.